Hey everybody, this is Brad Dyke saying hi, how you doing? At a point in stage now where we're going to talk about some really cool stuff. The last two videos I made was in preparations and coordination with me going from a 1 gigabit architecture in the overall bus of my home to, and that's all the way out to the ISP by the way, to moving to a 10 gigabit base bus speed for network bandwidth in the house, with the ISP being the slowest pipe out there. And so I've been reaching out there, and I bought a switch here, and I bought parts there, and I'm recycling old gear because 10 gig is actually fairly cheap. It's in the $100 to $200 range. And so let me show you what I've been talking about. So right down here, you've seen this switch already. I just cleaned it up recently and made it look brand new. And I've got 24 ports here. They're 10 gigabit. And then I got the new daughter card in that basically allows for me to go up to 4 GBIC interfaces. And I'll use 2 of those for sure. But I'm going to cap the other 2 as backups for later. And that's 10 gigabit. And it's going up to a 10 gigabit 8-port switch. Will also chain to my other 10 gig switches in here in the lab. But this will be in the lab. This will be down in the third rack down in my basement. The reason why is because it will cover all the port connectivity I need for the house, as well as give me 10 gigabit copper bandwidth up to my lab, which is the big perk here. That's the big reason why I'm doing this. So this switch I got for basically about $160. It's a 10 gig switch, lots of bandwidth. It's a Dell Series 4032 switch, 10 gig. 2410 GB, and I've got my good top 8-port gigabit GBIC based switch, which I've got 3 RJ45 10 gig outbounds and a 10 gig pipe direct copper right here, which is going down to this guy. So the secret sauce here is that usually happens and becomes a mistake is that people don't test the gear they get fully when they get it. So I've got myself a little RJ45 pairing up wire here, which is what I need. Of course, I need power. I need a laptop to give me what I need for communicating to these switches to make sure that all these ports are active. Then you want to cycle through all of these ports to make sure, if you've got any bad ones, to put blank heads inside them and cap them off so that they don't get used in the future. So with that being said, there's still very much a value here with basically setting this up. Now, usually what you do is you will have a Cat5 to your infrastructure. And I recommend that you do it this way, because once you start testing ports, use a 10 gig switch to 1 gig switch for bandwidth testing. The reason why is because you don't want to run the risk of plugging in a bad port in a brand new switch to the old switch and frying both of them. You don't want to do that. You want to use an old switch. You know, if you lose a port or two, it's not a big deal. The key thing is that you are being able to do what you need to do and that you're in good shape to do it. So that's the key detail. You can also use the same bridging connection for your RJ45 Cat5s, which are right here. Actually, no, Cat5s are actually equivalency 10 gig Cat6 plus or better. And the goal there is to make sure that you are testing those ports as well to make sure that the GBICs that you got work correctly. So with that being the case, the very first thing you do obviously is you want to get out the manual, which is right here for the 2 switches, and you want to basically follow the directions to set the switch up. What does that mean? Well, a lot of times people will use 192.178 or 168.0.254, 253, 252, and so on to represent their switches. But in my environment, if I did that, it would compromise the switches I already have in play. So what I have to do is I have to identify all the switches out there and make sure that none of them are fighting with any of the other ones. So what that basically means is I'm going to, but after I do this test, in my next video, I'm going to show you how you'll map out your topographies of your managed switches and make sure that you compartmentalize your IP scopes as you use 172 or 10.0 or 192.168, whatever you're choosing to use as your preference NAT translation network. And that allows you to be able to make sure you're swapping old for new. So I have one Netgear 5448, which is a big boy, 48 ports. I don't need that kind of firepower. I am thinking about maybe relocating it here, but I haven't decided yet on that. The key thing is it's my core switch for the entire house. So that one's got to go. It's like 10 plus years old. It's been a great switch. I'll probably move it into the lab as I retire the Nortel 6200 and let them switch off from each other's rules. I use the 1 gig switches for things like front ending for IPs, or if I want to do like thin clients, give them a lot of connectivity, Pis, Raspberry Pis, things like that. I don't want to eat up a 10 gig port for something that should be nothing more than a 1 gig port. So with that being the case, I'm not going to do the logins into the switches this time. What I am going to do is I'm going to show you what it sounds like when these things power up. Now I'm going to go ahead and change my structure here a little bit, and so you can see. Now the cool thing about our little guy here is that that's just it. He's a little guy, right? And that's important because what I want to do here is I want to make sure that that switch powers up and I can do some checking with the switch ports and so on and so on. So I'm going to put this guy in. I'm also going to go ahead and remove these guys. Come on. I don't want them out, do they? All right, well, anyways, as you can see, it's beginning to power cycle. And I'm going to use these RJ45 heads to basically test these ports. I'm going to take the covers off. It really would suck if I found out that all my ports aren't active, right? It won't work. So I'm going to go ahead and pull this one out too. And that one's free. And as you can see, even my GBIC that is plugged in is not active. So it's posting right now, so we're going to give it a second to post. And we're going to use an RJ45 base cable connection here to test these out to make sure that we have link up. Link up is very core. It's very simple and very basic. But now that we are not blinking our lights, we can now start testing these ports. So I'm going to put one in here. And oh, it's still in boot up process. Hang on a second. Okay, so as you can see right there, right under the GBIC, you have a blinking LED. So that tells me that this guy is good. So I'm going to go ahead and unplug this. And I'm going to put another one in. And this time I'm going to kind of compound it. And I'm going to start stepping through these ports one at a time. But I'm doing them on a principle of basically 3 at a time. Still waiting. There it is. Green light. Okay, so this one's good. Doing the next one. That one came up good. Doing the next one. That one is good to go. So I'm going to go ahead and start, prepping the release of these ports and moving on to port 5, 6, and 7. Now I know a lot of you might think, well, this is kind of superfluous if it's a brand new switch. No, it's not. There are a lot of scams out there, and they do little things to trick you. And scams that which are applicable to your GBICs, to the switches themselves, to even backdoor caching. You know, they do these little things to undercut their costs so they can make a little bit more money off of you with less features and functions than you thought you bought. So it's advantageous to check the ports as you go through them and get them going. So we're checking the ports now on this one. Checking the export. That one came up. Checking the next port. That one came up. Checking the first one again. That one kind of took a little long to come up. Port 6 might be a problem. All right, just to make sure it's not the GBIC, we're going to take that out. Put this guy into there. Good. I'll take this one out also and put that one into here. So now I've got these two broken out. I'm going to retest port 6. Came right up, so this GBIC might be a problem. And then checking the last one. And it came up just fine. So yeah, I do suspect that I have a bad GBIC here. So that being the case, I'll set him aside. But now what I'm going to do is I'm going to unplug this guy. We're going to decommission him for a bit. And you guys get to hear the wonderful noise and excitement of this Dell switch powering up. This is going to be a little noisy at the beginning, but this little, no, it's not little, it's a full-size switch, has redundant power supplies, redundant fan assemblies, and it gets a little noisy on the spin up. So I'm going to go ahead and grab the two power cables, these guys right here, and I'm going to plug them in the back. And like I said, it's going to get a little noisy. All right, with the Dell 4032, we're also going to discover that it's going to do nothing for quite a while, because it takes almost 5 minutes for this switch to boot up. And over here on the back end, you can see the LED lights down there, and when they process and bring up the prompts, then I can start testing this switch out. So we're going to move this guy over here and point this down. Now, to effectively test this correctly, I am going to have to use my new 10 gig switch for the 4 quad checks. And I can't use these GBICs because these are RJ45 based. I have to use either copper direct or fiber. Okay, so that means I have to use this connection, and I'll put it in here into port 1. And then I'll put this guy right here, and that will allow us to check these 4 ports right here. Okay. Now I'm going to go ahead and power that one up. Okay, so now that's powering up and cycling. And now you're hearing the volume of the fans drop as the switch begins to nominalize. And down here you have a notification that you're in the process of posting. Okay, so now we got a green cycle. The red light is gone. It's now green. It's now blue, I should say. And we're able to now begin testing. So we're going to first start off by using the cheap 1 gig network connection, this guy right here. And we're going to start testing these guys to make sure that they come up. It's still posting. But I can go ahead and put this in. We'll give it a minute to finish its post. You'll know it's finished is when it starts actually activating the lights on the RJ45 heads and or the actual GBIC slots over here for the SFP Plus connections. Okay, so port 1 and port 2, they test good. And I'm just going to start walking through them to make sure I've got good active connectivity. That's good. 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 And that is good. And stand by for a second and I'll finish the other 12 ports real quick. Okay, so all 24 ports test good. And now I'm testing my 10 gigabit port connections. And I'm looking at it right in the front and showing green light for 10 gig. And I'm showing the same thing for the GBIC connection and the new switch. I'm going to pull this guy out. I'm going to test the next one. Port negotiation. Yep, we are good. Alright, so it came up. And the light is, oops, sorry. And the light is blue, so that's 10 gig. Checking the next one. Yep, we are good. And I'm checking the last one. Yes. So that means this is good. I'll go ahead and bring these down. Okay, so now what I'm going to do is I'm going to sequester channel A versus channel B, which basically means in a nutshell that my 10 gigabit connectivity will be prepped to each channel of the configuration card. Now, what do I mean by that? All right, let me explain. Network cards, when they have more than a single bus, or basically a single port, they basically have, they kind of split it up, if that makes any sense. And so these are block sectionals that each have their own little bus. Now that common bus is in the back end that I showed in the photos earlier in the process. And those would break these down and segment the bandwidth and the usage speeds across these multiple channels. Now the same thing exists with a daughter set. Usually it's done by every two. So alpha, bravo, alpha is 1, bravo 1. These are zeros, these are ones. And these ports are separated buswise. So if you want to really maximize the effect of your connectivity, only put a port on each channel one at a time, and you're going to get the bandwidth sustainment really nice. And this is a big problem with some of these smaller kind of switch hubs that you might get that have a lot of ports on them, but they kind of lie to you because they basically pile more ports on single channels, and then they can't figure out why is it so slow. That's the reason why. Too many resources sharing the same channel. But if you have a split channel like this card is designed to do, this gives you the ability of giving you the maximum output of that 10 gigabit port that this port won't see that traffic on. So those are valuable. So with that being the case, the next part of this equation is, what do we do next? Well, in this first 30-minute segment that we just did here, is talking about you bought stuff on eBay, right? You're not sure if it's good or not. And if it's not good, what do you do? Well, you don't just arbitrarily start setting the stuff up and putting it into use, because you're going to discover along the way that some of the stuff, the brand new stuff, like i.e. this GBIC card right here, is defective right out of the manufacturing warehouse. So you have to QA your gear. And that's what this video is about. QAing, quality assurance, basically, also referred to as QA, is to make sure that your hardware is going to meet the expectations that you're looking for. You need bandwidths to be bandwidths matching in the right places. At that point in stage, it also allows you to check and test your subject equipment, such as cabling and so on, to make sure you've got the right kind. So my next video will be about staging the iOSs of these platforms. And once we get those set, and I'll have my targets out there as well, by the way. And the targets basically are going out there and making sure that what I'm replacing, I've identified those resources, and that I'm swapping them as in accordance. Because switches own IP addresses, and when I start to enable IP6 across my infrastructure, these environments have got to support it. Now remember, antiquated equipment, old equipment basically, loses a lot of firepower in its caching when it has to double down on the resources to maintain IP mappings. In other words, the MAC address is associations of IP6, which are double that of IP4. So that's why a lot of people will take steps to basically get more modern equipment that at least has a little bit extra memory on board to handle that flip over from IP4 to IP6. Now, an alternative you can do with that is you can use the NAT front ending for IP6 and your IP4 on the back end. That also works. It's not always a great solution, but it for the old school who like IP4 because it's easier to type out in your hand than trying to type out the value of a IP6 value. This tends to work out pretty good for your needs. So with that being said, that's what we'll cover in the next stage, and that is to stage the architecture, make sure the bus is right, put my master switch in, leave everything alone, but put the master switch in alone. Swap apples to apples each time, and as you do that, remember my core switch is a Netgear 5348 switch, and I want to only replace that one switch initially, and I'm not going to add the new switch to the equation because this guy has no IP, has no resources. He's not a problem. The problem is the new core switch. It's got to replace all the IP aspects of the switch that is in use now. Then I go through and start doing initial bandwidth testing. You see, I have fiber in the building. The fiber runs, 2 pairs of fiber run between my lab and the downstairs basement. And I also have 2 Cat5s out there as well. And I am tempted to maybe set up a little bit of adaptive load balancing strategies but I haven't made that decision. I might actually choose to separate them completely. Use one fiber pair on one switch, i.e. like this, and use another pair on another switch, which I already have in place and it's already hooked up. So it's just a matter of me hooking this guy up, and that's it. Then I take my 5348 switch after I reformatted it, and I will put it in using the Cat5 connections, I'm sorry, Cat6 connection, to bridge that connection over as well. And then I'll have a 48 port switch that can go to the core, and it's very slow bandwidth in comparison to the two 10 gig switches that connect up to the core 10 gig switch. And my house should be completely 10 gigabit across the board. Only thing I need to do now after that is to buy a 10 gigabit or better NIC card for my server workstation in my office, and might beef up my workstation's bandwidth as well for the grin of it. But for this video, that's it. This is Brad Dyke signing off, saying thanks, guys, for just taking a little bit of time to learn the pre-steps of transitioning the hardware, which I purchased and staged. And now I'm going to be getting the process of swapping them. And we'll get that set up. We'll do a video on the core switch and the proper diagnostic steps to help you bandwidth check your bandwidth functionalities. And you can actually do it without transferring giant sums of data, by the way, because you're not going to transfer giant sums of data from a core switch to your lab switch. The lab is going to do all the high-speed transfers inside that architecture. There are other ways you can do to determine, the bandwidth capacity. And you would do that based on the switch's telemetry itself. But like I said, this is Brad Dyke signing off. I hope you guys have a great week and weekend, and God bless. Bye-bye.